Mysterious music plays as camera pans across the Antikythera mechanism. Welcome to the shadows of history, where the fingerprints of genius have left their mark across millennia. I'm Professor, and today we're venturing into the enigmatic world of ancient scientific achievements, discoveries and innovations so profound they continue to baffle modern minds. The device you're looking at is the Antikythera mechanism, recovered from an ancient shipwreck. Dating to the 2nd century BCE, this mechanical computer predicted astronomical positions and eclipses with astonishing precision. Yet this is merely one fragment of the vast scientific legacy our ancestors have left us. While our modern narrative often portrays ancient civilizations as primitive or superstitious, the evidence reveals a more perplexing truth. They possessed knowledge so sophisticated that some of their achievements remained unsurpassed for thousands of years. Today, we'll journey across 5 ancient civilizations: Mesopotamia, Egypt, China, India, and Greece, to unravel the mysterious origins of science itself. We'll explore achievements from roughly 3000 BCE to 500 CE, a vast period during which the foundations of modern knowledge were being quietly laid by minds that questioned the universe just as we do today. Timeline appears showing key achievements across civilizations. The tapestry of ancient science wasn't woven in isolation. Knowledge flowed along trade routes, was preserved through dark ages, and emerged transformed in new cultures. As we explore each civilization, notice how ideas echo and evolve across continents and centuries. What's particularly enchanting is how these ancient scientists achieved such precision without modern tools. Their insights arose not from technological advantage, but from careful observation and mathematical thinking that would still be considered rigorous today. Let's begin in Mesopotamia, the cradle of civilization between the Tigris and Euphrates rivers. Here, amid the first cities humanity ever built, the Sumerians, Babylonians, and Assyrians crafted the earliest scientific systems. Perhaps most captivating is their astronomical knowledge. By 3000 BCE, Mesopotamian astronomers were meticulously recording the movements of celestial bodies. The clay tablets of the Venus tablet of Amisajuka reveal observations so precise they allow modern astronomers to calibrate ancient calendars to our own. Illustration of sexagesimal system and astronomical calculations, the mathematical legacy of Mesopotamia continues to shape our daily lives in ways both profound and overlooked. Their sexagesimal, base 60, system still governs how we measure time: 60 seconds in a minute, 60 minutes in an hour, and angular measurement 360 degrees in a circle. The baffling Plimpton 322 tablet from 1800 BCE contains what many scholars believe to be a trigonometric table, displaying Pythagorean triples over 1,000 years before Pythagoras was born. Such knowledge wasn't merely theoretical. It enabled the construction of irrigation systems and ziggurats that defied the engineering capabilities we once thought possible for the era. Camera pans across the Great Pyramid of Giza moving to Egypt. We encounter monuments so precisely constructed they've inspired countless theories about extraordinary knowledge. The Great Pyramid of Giza aligns to true north with an accuracy of 0.05 degrees, a feat that would challenge modern builders even with advanced equipment. But how could the Egyptians achieve such precision? The answer lies in their profound mathematical understanding. The Rind mathematical papyrus reveals sophisticated methods for calculating area, volume, and proportions, essential knowledge for a civilization obsessed with architectural harmony. Images of medical papyri and surgical tools, perhaps even more perplexing, was ancient Egypt's medical knowledge. The Edwin Smith papyrus, dating to around 1600 BCE, but likely copied from texts 1,000 years older, contains descriptions of the brain, spinal cord, and their relationship to bodily functions, knowledge supposedly not discovered until much later. Egyptian physicians specialized in different areas of medicine, conducted examinations, made diagnoses, and prescribed treatments with a methodical approach that foreshadowed modern medical practice. Their pharmacopoeia included over 700 remedies, many of which contained active ingredients still used in medications today. Across the world in ancient China, equally mysterious achievements were unfolding. While Europe would wait until Johannes Gutenberg in the 15th century for the printing press, the Chinese had developed movable type printing by 1040 CE. But this was merely the culmination of a scientific tradition stretching back millennia. Chinese astronomers recorded observations of comets, sunspots, and supernovae with astonishing detail. In 1054 CE, they documented a guest star so bright it was visible in daylight. What we now know was the Crab Nebula supernova, whose remnants are still studied by astrophysicists today. Demonstration of seismoscope and compass. One of the most enchanting Chinese inventions was Zhang Heng's seismoscope from 132 CE, a device that could detect earthquakes hundreds of miles away and indicate their direction, a capability Western science wouldn't match for nearly 2 millennia. The Chinese understanding of magnetism led to the invention of the compass, revolutionizing navigation worldwide. Their alchemical experiments, while searching for immortality, produced gunpowder and countless chemical discoveries centuries before similar knowledge emerged elsewhere. In ancient India, mathematical innovations emerged that would transform science forever. The concept of zero, not merely as a placeholder, but as a number in itself, and the decimal system we use today originated in Indian mathematics. The perplexing precision of ancient Indian calculations is exemplified in texts like the Surya Siddhanta, which calculated the Earth's diameter to within 1% of the actual value, and estimated the length of the solar year to within 3 minutes of the modern calculation, all without telescopes or modern instruments. Images of surgical instruments and the iron pillar of Delhi Indian medicine, particularly surgery, reached heights that wouldn't be matched in Europe until the 19th century. Sushruta, the father of surgery, described over 300 surgical procedures and 120 surgical instruments in the 6th century BCE. His techniques for rhinoplasty, reconstructing noses, were so effective they were adopted by Western surgeons in the 18th century. Perhaps most baffling is the iron pillar of Delhi, standing 23 feet tall and weighing over 6 tons, which has resisted corrosion for over 1,600 years. Modern analysis reveals it contains phosphorus in precisely the right amount to create a protective layer against rust, a metallurgical achievement that would be challenging even with contemporary knowledge. Finally, we arrive in ancient Greece, where philosophical inquiry merged with observation to create what many consider the first truly systematic approach to science. Democritus proposed that all matter consisted of indivisible particles called atoms, an insight verified only in the last few centuries. Eratosthenes calculated the Earth's circumference to within 2% of the actual value using only shadows and geometry. Hippocrates established a medical tradition that separated illness from supernatural causes, laying the groundwork for rational medicine. Recreation of Archimedes' devices and Antikythera mechanism, the Greeks excelled in mechanical knowledge as well. Archimedes' screw still inspires modern pumping mechanisms. His work on levers and pulleys established mechanical principles we still teach today. And returning to where we began, the Antikythera mechanism demonstrates mechanical computing techniques that wouldn't reemerge for another 1,400 years. What makes these achievements truly enigmatic is that they occurred without the infrastructure of formal scientific institutions. Knowledge was passed from master to student, preserved in texts that were often lost and rediscovered, and sometimes emerged independently in multiple locations, as if the universe itself were whispering its secrets to those patient enough to listen. Images showing knowledge transmission through the ages, the tapestry of ancient scientific knowledge wasn't woven continuously. The burning of the Library of Alexandria, the fall of Rome, and countless other historical ruptures threatened this precious inheritance. Yet somehow, core insights survived preserved in Arabic translations, Byzantine encyclopedias, and monastic libraries, only to re-emerge during the Renaissance. This mysterious transmission of knowledge across time raises profound questions. How much ancient wisdom have we lost? What techniques and insights might we be rediscovering rather than inventing? And most intriguingly, what approaches to scientific problems might the ancients have pioneered that our own technological focus has caused us to overlook? Modern scientific imagery, intercut with ancient achievements, as we stand in our modern laboratories, peering through electron microscopes or launching telescopes into space. We might feel separated from these ancient pioneers by an unbridgeable gulf of technology. Yet, in the most profound sense, we are continuing their work, asking the same essential questions about the nature of reality. When we measure time, we use the Mesopotamian system. When we calculate with zero, we employ Indian mathematics. When we build according to geometric principles, we follow Egyptian and Greek insights. The ancient scientific achievements we've explored today aren't just historical curiosities, they're the foundation upon which our modern understanding rests. Join us next time as we explore scientific revolutions, the moments when humanity's understanding of the cosmos transformed dramatically, reshaping our place in the universe itself. Music swells as video fades to closing graphic.